Hello viewers, today we have a simple task. So just solve a few questions on work done. So just solve two questions on work done. So we have our question number one, which is saying a block of mass of 2.50 kg is put through a distance of 2.20 meters along a horizontal table by a constant applied force of the magnitude of 16 newtons. So A is asking us to say how much work is done by the applied force if theta is 130 degrees. How much work is done by the applied force if theta is 30 degrees. So we can see this is a diagram trying to show the block that is being put, that is through a distance of 2.20 meters along a horizontal table by a constant applied force of 16 newtons. So you can see the force is being applied at an angle here, and this block is being put in the positive x direction. So the movement of this block, it will be in the positive x direction. So that will be the movement of the block. So A is asking us to calculate the work done by the applied force if theta is 30 degrees there. So remember, if we try to redraw this block so that we see the forces that are acting on this block, so this is our block that this is a block that we have here. Okay, so this block is just on a horizontal table here. Okay, and the force being applied, the size of the force that is being applied is 16 newtons as indicated in the question, and this force is being applied at an angle, and they've indicated to say theta is 30 degrees. So that's the angle at which this block is being put at. Okay, so to calculate the work done by the applied force, remember the movement of this block will be happening in the x. So the movement will be happening in the x there. So since the force is applied at an angle there, this system, it will have two components, that is the x and also the y component. Okay, since the force is acting at an angle, therefore it will have the x and the y component. So we have the fx, which is what we call f, that is cos theta, and also we have the force in the y, so this is f sine theta there. That's what we have. So since this block is moving in the positive x direction, so the only force that we're going to use, it is f cos theta. Okay, so we are calculating the work done, remember. So we're going to say the work done will be equal to the force, that is times the change in displacement. That's the general formula that we use. So the work done is equal to, since the force is being applied at an angle there and the movement will happen in the x, so that force, it will be f cos theta. We'll consider the angle, so it will be f, that is cos theta, times the change in displacement. So the work done by the applied force will be equal to the force being applied is 16 newtons, then the force is being applied at an angle of 30 degrees. Then this block is being put to a distance of 2.20 meters. So that one becomes the change in displacement, which is 2.20 meters there. So the work done will be equal to, so just punch that on our calculator. So should be able to get the work done, which is 30.5 joules. So this one becomes the work done by the applied force. Then we move to B. B is asking us to say, suppose nu k, which is the coefficient of kinetic friction. So suppose the coefficient of kinetic friction is 0.2. How much work is done on the block by the friction force? So suppose nu k has been given. So suppose nu k, which is the coefficient of kinetic friction, is 0.2. So how much work is done by the by the friction force. Okay, so we're looking for the work done, okay, by the friction force. So remember, as this block is moving in the positive x direction, there will be the friction force that will be opposing the motion. Okay, so that friction force will act in the opposite direction, which will be Fk there. So it will act in the opposite direction. So what we're just looking for is actually the same work done by this friction force that we have. So the formula, we say the work done is equal to the same friction force. Then we are going to multiply it with the same change in what? Displacement. That's the formula that we're going to use. So from here, what we need is the friction force, okay? And since we're given the kinetic friction of 0.2, we can get the friction force, which is just equal to the coefficient of kinetic friction times the normal force. So from this our formula, what we need is the normal force, okay? So remember, the normal force is the upward force. So on our system, the normal force here, it is the upward force, which is denoted by N, okay? So that will be the normal force. Remember, we also have the gravitational force, which will be acting downward there, okay? So we can see that from this our diagram, the normal force is an upward force, and it is along the y. So since the normal force is along the y, so for us to calculate this normal force, we are going to resolve all the forces that we have in the y. So we're going to resolve all the forces that we have in the y. That's what we're going to do. So we're going to say the summation of all the forces in the y. So number one, we have the normal force, which is the upward force, which will be considered to be positive. And also we have the Fy there. This force is also acting in the y, so it will be considered to be positive, which is F, that is sine theta. Then we have the gravitational force, which is the downward force, also acting in the y. So this will be a negative what? W there, okay? So remember, we're going to say the summation of the forces in the y should be equal to 0. So the reason is simple. So in the y, there is no any movement that is happening. So applying Newton's second law of motion, we can say force is equal to mass times acceleration there. So in the y, there's no any movement, so the acceleration will be equal to 0. Okay, so everything here will give us a 0. So no wonder we're going to say the summation of all the forces in the y should be equal to 0, because in the y there won't be any movement. So we have the normal force plus that is F sine theta minus the gravitational force, it is the mass times the gravity there. So what we're going to do is we'll make the gravity cross an equal sign so that it is positive, and also F sine theta, which will be negative when it crosses an equal sign. So this is equal to the normal force there. So we have our normal force, which is equal to our mass times gravity, that is minus, that is F sine theta there. So we are saying the normal force is equal to, remember this block has a mass of 2.50, that is kg. Then the gravity is 9.81, that is newtons per kg, minus, then the force being applied is 16 newtons, sine, then the force is being applied at an angle of 30 degrees there. So the normal force will be 2.50 9.81 minus 16 sine 30 degrees. So I'm getting the normal force of 16.5 newtons. So now we can calculate the friction force, which is equal to the coefficient of kinetic friction is 0.2. The normal force that we have calculated is 16.5 newtons. So the friction force here will be 0.2 times 16.5. So the answer will be 3.3 newtons. So remember, the friction force will be acting in the negative. It will be opposing the motion of this block. So it will be negative there. So you consider it to be negative. So now the work done okay, on the block by the friction force now here becomes the friction force negative 3.3. Then we're going to multiply this by the displacement, which is 2.20. Okay, if you remember. So the work done by the friction force will be 2.20 times 3.3. So it will be negative 7.26 joules. So we can see that the work done by the friction force on our system there, it will be equal to negative 7.26. So that's what we do. Then we have our last part. So the last part, that is C. So C is asking us to calculate the total work done. Okay, so C is asking us to calculate the total work done on the block. So what would be the total work done on the block? So when you look at this our block, you're just adding all the work done by the friction force plus the work done by the kinetic friction, and also the work done by the normal force, plus also the work done by the gravitational force. So that is the total work done. So the total work done will be equal to the work done, that is by the applied force, plus the work done by the friction force, then plus the work done by the normal force, plus the work done by the gravitational force there. So the total work done here will be equal to, so the work done by the applied force, we found that was A, we found the 30.5 joules. Then plus the work done by the friction force is negative 7.26 joules. Then we're going to say plus the work done by the normal force. So the normal force is along the Y. So since there is no any movement in the Y, so the work done by the normal force will be equal to 0 joules, and also the work done by the gravitational force will be equal to 0 joules, because all these are acting in the Y. So the movement is only happening in the what? In the X. So that's why the work is being done. So now we have the total work done. So the total work done here, we have 30.5 joules. Then positive times negative, we have 7.26 joules negative. So the total work done here would be 30.5, that is minus 7.26. So the total work done will be 23, that is 0.2 joules. So that one becomes the total work done on the block there. Then we have our question number 2, which is our last question for today. So question number 2 is saying that a block of 10 kg is put on an inclined plane with a force of that is 20 newtons. The coefficient of friction between the block and the plane is 0.2. So a block of 10 kg is put on an inclined plane with a force of 20 newtons. The coefficient of friction between the block and the plane is 0.2. So we have A, which is saying calculate the work done by the block, calculate the work done by the applied force, okay, on the block if it is put through a distance of 2 meters and at an angle of 20 degrees there. So how do we calculate the work done? That is by the applied force if it is put through a distance of 2 meters and theta equal to 20 degrees. So that's the diagram which is trying to show what is happening here. So we have a block which is on an inclined plane here. So we can see that this block is placed at an angle there because this is an inclined plane. Okay, so this inclined plane forms an angle of 30 degrees. Okay, then the forces that are acting on this block, number one force, since we're saying this block is being put, okay, through a distance of 2 meters, that is in the positive x direction, as you can see. So this block is also being put at an angle there, theta. Okay, it is being put at an angle theta there. So if this block is being put at an angle of theta, we'll just extend this. So this is the force. So this force is acting at an angle. So therefore, meaning that we have the x component and the y component there. So this is what we have. So meaning that here we have the fx, which is equal to, that is f, we have cos theta, and this side we have fy, which is f, that is sine what, theta there. Okay, so now the question is asking us to calculate the work done, okay, by the applied force, that is A. Okay, so the work done by the applied force is equal to what? It will be equal to the applied force times the change in displacement. So the force is being applied at an angle there. So and the block will be moving in the positive x direction, but at an angle. Okay, so I'm going to use f cos theta there. So it will be f, that is cos theta, times the change in displacement. So the work done by the applied force, we have the size of the force that is being applied, if you remember. So the size of the force being applied in the question is 20 newtons. Okay, we'll collect our data. So the block has a mass of 20, that is kg. It has a mass of 10 kg. So the block has a mass of 10 kg. Then the force being applied is that is 20 newtons. Then the coefficient of friction between the block and the plane, that is new, it is 0.2. So that's the coefficient of friction there. So now the work done will be equal to the force being applied is 20 newtons, which is being applied at an angle of they are saying through theta, which is 20 degrees. So at an angle of 20 degrees times the change in displacement. So the block is being put through a distance of 2 meters. So that one becomes the change in displacement. So you just have to punch. So we have the work done by the applied force, which is 37.6 joules. So that one becomes the work done by the applied force. Then we have our B. So B is asking us to calculate the normal force. B is asking us to calculate the normal force. That's what B is requesting us to do. So remember, for us to calculate the normal force, on the diagram, we have the normal force, which is the upward force. So this normal force is along the y, okay? So for us to calculate this normal force, we're going to resolve all the forces that we have in the y, okay? So in the y, we can see that we have this line for the normal force, which is going like this. Then here we have the gravitational force, okay? So we have the gravitational force, which is acting at an angle of 30 degrees there. So now if we are to extend and connect there, we can see that this here we're going to form a 90 degrees angle. Then there they're telling us it is 30, okay? So since this gravity is acting at an angle, it has the x component and also the y component. So since this is 90 and the angle is here, so this side becomes cos there. So it will be mg cos theta. Okay. So this side we have that is mg, that is cos theta. Then this side, this is mg. Then this is sine what, theta. So we are just following this our right angle triangle. So since 90 degrees is here, the angle that has been given is right there. So here it is cos, which you can compare with this where the force is being applied there. We have the angle here and 90 degrees here. So this side is cos. So don't mistake it. Don't make a mistake by putting mg sine theta to say this is in the y. No, we've seen that when you resolve this the gravity, when you consider the forces that are acting, I mean at which this gravity is the forces that are acting on this gravity, you have the x and also you have the force in the x and also the force in the y there. So therefore you consider it like that. Okay, so now we are saying now for the normal force now, since we have now all the forces in the y, so we are going to say the summation of the forces in the y, because we are trying to find the normal force. So you have the normal force itself, which is positive, and also you have Fy there, this is in the y, so that is positive F, that is sine theta. Then we have minus, okay, this is the gravitational force which is acting at an angle, so you get is mg cos theta there. so it's negative, that is mg, then cos what, theta. So since there is no any movement in the y, so the summation of the forces in the y will be equal to 0 because the acceleration will be 0. So now we have the normal force plus that is F, then this is sine theta minus this is mg, this is cos theta there. Now if we are to make the normal force the subject of the formula, we'll make mg cos theta cross an equal sign, so it will be positive. So it's mg cos theta f sine theta, it will be negative, so it will be f sine theta. This will be the normal force. So the normal force will be just the mass times the gravity, then cos theta minus that is f, then this is sine theta. Now the normal force will be equal to the mass of the block. Remember, it is 10 kg, that's the mass of the block. So I have 10 kg. The gravity that we use is 9.81, that is newtons per kg. The angle now at which the gravity is acting, it is 30 degrees. I'm sure you can see. So the angle at which the gravity is acting on is 30 degrees minus the force being applied, it is 20 newtons. That's the size of the force being applied. So the force being applied is 20 newtons, which is acting at an angle of 20 degrees, not 30. Okay, so the normal force will be equal to, you're multiplying now. So we have the normal force, which is 78.1 newtons. So that's our normal force. Then now we move to C, which is asking us to calculate the friction force between the block and the plane. So since, remember, we have the coefficient, that is the coefficient of kinetic friction of 0.2, that has been given in the question. So for us to calculate the friction force between the block and the plane, we are going to say the friction force is equal to nu k, that is times the normal force. So the friction force here will be nu k, it is 0.2, the normal force that we have calculated, which is 78.0, that is 1 newtons there. So the friction force is 0.2 times that is 78.1. So we are getting, so the friction force is always negative. Okay, so not always negative, because the friction force will be acting in the opposite direction, which is there, and it has been indicated, so that will be the negative x. So that's why we put a negative. So it's negative 15.62, that is newtons. So that one becomes the friction force. Then now we have our D, which is asking us to calculate the work done, okay, by the friction force. So to calculate the work done by the friction force, it is just equal to the friction force times the change in displacement. So the friction force that we have is negative 15.62 newtons. Then the change in displacement, so the change in displacement is 2 meters. That's the distance at which the block is being put at. So now the work done now by the friction force will be equal to so the work done by the friction force here, it will give us that is negative 31.2, negative 31.2 joules. So that one becomes the work done by the friction force. Then now moving to E, which is our last part. E is requesting us to calculate the total work done. So remember, the total work done, it is the same as the net work done. So the total work done here, it will be the same as when they say the net work done. So the total work done here will be equal to what? On the system, we have the work, we're going to say the work done by the applied force plus the work done by the friction force, then plus the work done by the normal force, plus the work done by the downward force, which is the gravitational force. So the total work done will be equal to the work done by the applied force. We found 37.6, so that is 37.6 joules. So I have 37.6 joules. Then plus the work done by the friction force we found, that is negative 31, that is 0.2 joules. That's a negative. Then the work done by the normal force, remember the normal force is the upward force, so in the y there won't be any movement, so the work done by the normal force, see, and also the work done by the gravitational force will be 0 since there's no any movement. So 0 joules plus 0 joules. So the total work done will be 37.6 joules minus 31.2 joules. So the total work done is 37.6 minus that is 31.2. So the total work done here is 6.40 joules.